Right now, a piece of human engineering is hurtling through the dark vacuum of space at 17 kilometers per second. It is currently 25 billion kilometers away from Earth. Launched in 1977, Voyager 1 and its twin probe were originally sent out on a primary mission to execute flybys of Jupiter, passing the rings of Saturn, and reaching Uranus and Neptune. This 3D spatial schematic maps a major milestone the probe achieved in 2012. It shows the heliopause, the magnetic bubble created by our sun's solar wind. The trajectory line pierces the boundary where the sun's protection ends and the true void of interstellar space begins. It is the furthest any human object has ever traveled, entirely severed from the physical environment of the solar system that built it. Bolted to the side of this drifting probe is a golden record. It acts as a permanent physical repository containing the sounds, images, and data of human civilization. Etched into the cover is this geometric diagram. It plots a central point, our sun, connected by 14 lines to distinct nodes representing pulsars. Each displays a unique repeating wave pattern. Advanced alien intelligence could use these frequencies to triangulate the exact galactic coordinates of Earth. But our ability to monitor this beacon has a hard limit. By the year 2036, the onboard nuclear power supply will completely deplete. Every remaining active instrument on Voyager will shut down forever. What becomes of this physical emissary once its power fails and we can no longer hear its signal? Roughly 20,000 years from now, the dead, unpowered probe will pass beyond the Oort cloud, drifting silently past dense cosmic dust and massive, jagged, icy bodies to cross the true physical outer shell of our solar system. Looking back from that extreme distance, our sun would be completely indistinguishable from the countless background stars in the sky. Jump forward 40,000 years, and Voyager will make its first true close encounter with a foreign star system, Gliese 445. The probe will pass within 1.6 light-years of it. Because Gliese 445 is currently moving on a trajectory toward Earth, it will actually be one of our closest stellar neighbors by the time Voyager arrives. The machine has now transitioned into an independent galactic wanderer, separated from the star that launched it. Accelerating the timeline to 1 million years into the future, the probe will reach a distance of 57 light-years from where Earth currently sits. Despite spending eons in the harsh vacuum of space, the physical structure of the golden record holds up. Protected by its gold shell, it remains completely pristine, devoid of any scratches or cosmic degradation. Looking at this top-down vector schematic of our spiral galaxy, we can track the probe's progress out to 250 million years. Here, Voyager completes a full circular path, making its very first complete revolution around the galactic core. Human hardware is capable of surviving and tracking galactic timescales far longer than the civilization that actually built it. Projecting the timeline out to the extreme theoretical limit of 1 to 5 billion years, Voyager will complete dozens of these massive galactic orbits. Throughout these billions of years, the immense gravitational pull of 400 billion stars, massive black holes, and dense pockets of dark matter continuously drags on the probe, bleeding away its momentum. This data comparison chart reveals an absolute mathematical limitation. To overcome the galaxy's gravity and escape the Milky Way, an object requires a velocity of at least 550 kilometers per second. Voyager is represented by the tiny bar at the bottom, traveling at just 17 kilometers per second. Because of that massive deficit, Voyager's trajectory ends up bending back on itself. It hits a physical wall, meaning it will never break free into intergalactic space. It is locked in an eternal, closed loop. And while it orbits blindly, 5 billion years from now, our Earth and our Sun will likely have exhausted their lifespans and ceased to exist. Until humanity achieves the technology of a Type 2 civilization, capable of harnessing the total energy of a star to propel ships near the speed of light, we cannot break this physical barrier. Our farthest emissary and our ultimate physical legacy will remain forever captive within the borders of our galactic home.